Okay, so let's continue from where we left. We want to continue with this topic of time value of money. And before we continue from where we left, let me remind you what we said. Last time, we discussed how to compute, one, the present value and the future value. The present value and the future value of a lump sum amount. Tukasema, if you want to get the future value of a lump sum amount, you can get the discounting factor by using the formula 1 plus r to the power of n. That is the formula for getting the discounting factor for a future value. Then we said, another one, if you want to get the present value, future value is where you have maybe deposited an amount now, maybe 1 million in a savings account. You want to know what will it be 10 years from now. You get the future value. By what we said, you compound, okay? But what if you will receive maybe 10 million 5 years from now? You will receive 10 million 5 years from now. What is the present value of your 10 million in the future? What is the present value now? We say to get the present value, you use the formula 1 plus r to the power of negative n. In other words, we said you discount your 10 million. You will receive 10 million 5 years from now. What is the present value? So you do the discounting. You do the discounting. Now, to get these discounting factors, listen, you can use the calculator or you can use the table. Sometimes your examiner will give you the time value of money tables. Let me just give you an illustration. Assuming you are investing 1 million. No, you will get 1 million. You will get 1 million 5 years from now. You will get 1 million 5 years from now. You want to know what is the present value. To get the present value, you get the discounting factor. What is the R? Let us assume our R is 10%. How many years? 5 years. Okay? I have said, you want to know what is the present value of my 1 million 5 years from now. The amount in note is very important. You want to know what is the value of your 1 million that you receive 5 years from now. What is the present value now? So I've said you can use this formula to get the discounting factor, or you can use the time value of money tables. Sometimes they give you the tables. So if you have to use the formula, it will be 1.1 plus r. So r is 10%. R is 10% to the power of negative 5 to the power of negative 5, which will become 1.1 to the power of negative 5. So let me just use a calculator first to show how much that factor would be. How much is that factor? 1.1 to the power of 1.1 to the power of negative 5 gives me a discounting factor of 0.6209 to 4 decimal places. Okay, that is if you are using your calculator to get this discounting factor of the present value. But if you are given the tables, you don't need to use your calculator. You can use your table to get the same factor. Let me project a table here. Let me project a mathematical table here so that we see whether at 10%, remember the R is 10%, 5 years from now, what is the discounting factor? What is the discounting factor? So let me project the table. That is the table for what we are calling the present value. Are you seeing it there? That is the table we are calling the present value. Just a minute. Good. Here. That is the table I wanted to show. That's the table. You can see they are putting it up there. Present value interest factor of 1 shilling received at the end of each year. Good. The present value. You can see the formula there. You can even see the formula there. Good. So they are giving me the table for the present value interest factor. So I was saying our R is 10%. So you go along the columns. Along the columns, you look for your 10%. I hope you can see there. Then along the rows, you go to the extreme left, look for period 5. You come down, follow it. I hope you can see it here. I can see it here. The amount is here. 10% is here. At 5 years, the amount is 0.629. Are you seeing it there? That is the factor. That is the factor. That if you are using the table, then we are saying you don't have to use a calculator. If you are given the table, just go and use the table for the present value interest factor. Present value interest factor, you can even see it here. They have indicated present value interest factor. So you go to row number 5, and you go to column 10%, and I can see it's given to me as 0.629. Good. That's what we are trying to say on how to use the table. You can see it is the same amount I got here. It's the same amount I got here. Okay. So if you can't remember the formula and they have given you the mathematical the tables, go and use the tables for the present values. Good. So that was just by the way. Now we finished. After we finished the discussion of how to get the present value and the future value of a lump sum, we went further now and discussed how to determine. The future value. The future value of annuity. The future value of an annuity. And we said, this is just a reminder. We said there are 2 types of annuities. One is what we were calling the ordinary annuity. I hope you remember that. What we were calling the ordinary annuity. And number 2, what we were calling annuities due. And we said to get the ordinary annuity, it is that annuity that comes at the end of the period, at the end of the year or at the end of the period. Meaning, for example, you will be paying 1 million 1 year from now, at the end of year 2, at the end of year 3. Those are what we call annuities. Okay? Or you will be receiving, whichever the case. So you will be receiving or paying at the end of the period. Okay? You will be paying 1 million, 1 million, 1 million, 1 million. Okay? Or you will be depositing 1 million, 1 million, 1 million at the end of each year. So you want to know what is the future value of my 1 million. For the next 5 years, I'll be depositing 1 million, 1 million, 1 million, 1 million at the end of each year. What is the future value? Alternatively, we said you may be depositing your 1 million at the beginning of every year. Every year. So that is what we called an annuity due. So we said annuities due are those annuities that come at the beginning of the year. At the beginning of the year. Good. Then we gave the formulas. I hope again you remember. We gave the formulas for how to get the future values. How to get the future values. How to get the future value of ordinary annuity. How did we say? It is the annuity itself into 1 plus r to the power of n minus 1. Everything you divide that by r. You remember? That was our formula for getting the future value. That was the formula for getting the future value of an annuity. Ordinary annuity. Okay? Then we also said, what about if it's an annuity that is due? Don't forget I said for ordinary annuity, Those are annuities that come at the end of the year. You are investing 1 million at the end of each year. At the end of each year. At the end of each year. You want to know, if I do that investment every year at the end, what will be the future value 10 years from now? What will be the future value 10 years from now? And I told you, listen, for ordinary annuity, what you deposited in the first year, you will earn interest for it in the second year because you deposited it at the end of year 1. So we said for ordinary annuity, you lose 1 year's interest. But if you deposit the amount at the beginning, which becomes an annuity due, then we said if you deposit at the beginning of the year, your 1 million, that 1 million will earn interest even for that year. So we said the formula for future value of ordinary annuity, for annuities due, it is the same as that of the ordinary annuity, except, listen, except we said you now added the extra 1 year interest. I hope you're getting, because I told you for ordinary annuity, you are investing at the end of the year. So your 1 million will not earn interest in the first year. The one you deposited at the end of year 1, it will earn interest from year 2. So you lost the interest for that 1 year, first year. But when it comes to annuities due, and you deposit the 1 million at the beginning of the year, then that 1 million will earn interest for that year. Whatever you deposit in the second year will earn interest again in the second year. So we said for annuities due, now you add interest for another 1 year to the one of the ordinary. So it is the same formula we said, which is 1 plus r to the power of n minus 1, everything divided by r. But this time we said you multiply that by 1 times 1 plus r. We multiply that by 1 plus r. 1 plus r is, if the rate is 10% every year, it will be, you are multiplying by 1.1 to add an extra component of interest every year. Good. That was just a reminder. Then the other key important thing I need you to remember, we said, listen, these are the formulas for compounding. These are the formulas for compounding annually. Otherwise, I told you where the question is one, where you are compounding either semi-annually or quarterly or maybe monthly, we said the formulas remain the same, except that now you divide r by what? We said you divide r by m, which is the number of frequencies. The number of frequency in a year, okay? Or the number of compounding in a year. So you divide the rate r, our r is the nominal rate, you divide it by the number of compounding, the frequency. If the compounding is done semi-annually, you divide your r by 2 so that you get the rate per 6 months. If the compounding is done quarterly, you divide the r by 4 so that you get the rate per quarter. If the compounding is monthly, you divide the r by 12 so that you get the rate per month. Good. Then whenever there's n, we said you multiply that n again by the frequency m to get the number of compounding that will be done. If the investment is for 5 years and you are compounding semi-annually, then we said our frequency of compounding being twice every year, you are investing for 5 years, then your investment will be compounded 10 times, which is 5 years times 2 every year, twice every year. That means you will be compounded 10 times. Good. That is just a reminder. So today, we want to move on now. This is what we had just said. So today we want to go on and discuss how now to get the present value. This is the future value. This is the future value of an annuity. We had discussed for lump sum. We had discussed both the future value and the present value for lump sum. Then for annuity, we had only discussed the future value of an annuity, either ordinary annuity or annuities due. Now today, we want to proceed from there and now discuss how do we get the present value? How do we get the present value of annuity? Present value of annuity. Present value of annuity. That's what we want to discuss today. Okay? So let me introduce it now. Let me introduce it. Again, there are two types of annuities. There is one we are again calling ordinary annuity. And two, there is that which we are calling annuities due. Ordinary annuities are those annuities that come again at the end, while ordinary annuities due, are those which come at the beginning. So you want to determine the present values. Okay, let me explain. I'll be investing 1 million at the end of every month or every year. I'll be investing 1 million at the end of every year, at the end of every year, at the end of every year. I want to know for the next 10 years, if I keep investing 1 million, 1 million, 1 million, what is the present value of those annuities? What is the present values of those annuities? Now, again, there is a formula for it. There is a formula for it. You want to get the present value of the annuity. So it will be the annuity into, now the formula changes. It will be 1 minus into 1 plus r to the power of negative n. Everything you divide by r. Everything you divide by r. That is the formula for getting the present value of an annuity. Okay? Now, listen again. Listen carefully. Listen. When I was introducing the first part, which was the future value of annuity, I told you this. That where the question is an annuity one, listen, an annuity one, and, listen, and the question you are given for annuity is maybe for 3 years or 4 years, then I told you, if you cannot remember this big formula, if you can't remember this big formula, then I told you, you can use the future value, formula for a lump sum. But you keep repeating it, How is the future value? The future value of a lump sum is this. And so I told you last time, just to reconnect, that if you are given a question where the annuities are only for a few years, for the first 4 years and so on, then if you can't remember this formula, then we said you can get the future value by saying it will be r into 1 plus r to the power of, assuming the annuities are for 4 years. Okay? Annuities are for 4 years and they are coming, listen, and they are coming at the end of the year. At the end of the year. You are investing, listen, let me review. You are investing 1 million, 1 million, 1 million at the end of each year for 4 years. So your first 1 million, listen, your first 1 million in year 1 will only earn you interest for how long? It will not earn you interest in the first year. It will only earn you interest in the second year, third year, and fourth year. So we said your power there will be n minus 1 because you are investing for 4 years. Okay? You are investing for 4 years, but the first year you will not earn interest because you are investing at the end. Then, which is the same as saying your first year you will only earn interest for 3 years plus. Then I told you it will be r again plus 1 plus to the power of n. What you are investing in the second year, will only earn you interest in the third year and the fourth year. Those are 2 years. Plus, what you are investing in the third year will earn you interest only in the fourth year. So it will be r into 1 plus r to the power of 1. Then finally, what you are investing at the end of year 4 will earn you interest will not earn you interest. So it will be R into 1 plus R to the power of 0. And I told you last time, anything raised to the power of 0 is 1. Anything raised to the power of 0 is 1. So I hope you can remember this argument. So that is, if the question is one where the examiner has given you annuities for a few years. So you can use the normal formula of 1 plus R to the power of n if you can't remember these long formulas. Okay? If you can't remember these long formulas. Now listen. The same thing also for annuity. When you want to get the present value, this is the formula. But let us assume that you can't remember this formula. But you know the formula for getting the present value of a single amount. What is the formula? We can now say here, recall the present value of an lump sum amount. It's 1 plus R to the power of negative what? The power of negative n to the power of negative n. Listen, you are investing 1 million, 1 million, 1 million, okay? You want to know, if I put in 1 million in the bank 1 year from now, because these are at the end, we are dealing with ordinary annuity. If I put in 1 million at the end, I put another 1 million at the end, another 1 million at the end of year 2, another one at the end of year 3, another 1 million at the end of year 4. What is the present value now? What is the present values? So it means if you go by the shorter one, then I said it will be present value equals to what I put in. What I had put in by end of year 1, what is the present value? So you bring it backwards. Listen here. This is year 1, year 2, year 3, year 4. So you want to get the present value, you bring it backwards only once. The second year, what you put in the second year, you want to know the present value. You bring it twice backwards. Remember, this is year 0. You are at that point where you want to get the present value. What you invested in year 3, or what will be in the account in year 3, how much will be the present value? Bring it backwards. So if you are using this short formula, then the present value of your annuities will be R into 1 plus R to the power of negative 1. What I invested, or what will be in the account by end of year 1, what is the present value? I only bring it back once, okay? Plus R, what will be the annuity of year 2? I'm going to receive 1 million at the end of year 2. What is the present value now? So it will be 1 plus R into power of negative 2. Are you saying? Plus R into 1 plus R. Third year, I'm going to receive another 1 million. These are annuities. What is the present value now? So that is to the power of negative 3. And that way. Now listen, I told you, the only problem is when the question is one for many years, 15 years, 20 years, and so on. And maybe also, listen, and maybe also the examiner has not given you the table or the present value of annuities. If he gives you the table, that's okay, you can use. We shall look at how to use them. But let me just use a simple illustration just to illustrate if you are given the table and if you are not given the table. Now, so we want to say you want to invest, or you are getting annuities of 1 million, 1 million, 1 million. That is your annuity. Every year you will be getting that at the end. Our R, I want to assume again, is 10%. Our R is 10%. After 5 years, the investment is for 5 years. I'm going to be receiving 1 million, 1 million, 1 million. What is the present value of that 1 million? So I'll take this formula. Let me get the discounting factor. Let me get the discounting factor. If I take this formula, let me put it, now we see together. It will be 1 minus into 1 plus 0.1, which is 10%, the power of negative 5. Everything you divide that by 0.1. That will be my discounting factor. What will it be? I am looking for the discounting factor. If every end of the year I'm receiving 1 million, it's an annuity. It's an annuity. What will be the present value now? So you get what we are calling the present value interest factor of annuity. What is the present value interest factor of annuity? Let me work it out. Let me take the 1 plus 1, 0.1. 1 plus 0.1 is equivalent to 1.1. I multiply that by the power of negative 5. Whatever I get, let me subtract 1. Then whatever I get, I divide that by 0.1. From this calculation, I am getting a factor of 3.7907. No, make it 8 to 4 decimal places. Make it 8. Good. That is if I am using the calculator to get the discounting factor. And that is the formula. Now listen. If the examiner gives you the table, you go to the table of the present values of annuities. You go to the table for the present value of annuities. So let's go and see whether we have been given. Let me roll my table. That was present value of 1 shilling. What about for annuities? Let me roll and see whether we have been given for annuity. Good. If you look at this second table, we are given present value interest factor for annuity. Present value interest factor for annuity. Our R was what? 10%. Are you there? Our R was 10%. Our N was what? Our N was 5 years. Our N was 5 years. So again, go to the column of 10%. Are you there? Go to the column of 10%. Then go to the row of 5 years. You go to the row of 5 years. If I go to the row of 5 years and I join it with the column of the 10%, I can see the amount is 3. Are you seeing it there? The amount is 3.7098. 3.7098. Is it what we have just got in the calculation? Let me see. Is it the same amount we have got in the calculation? Good. Yes. So what I'm trying to say is this. If the examiner gives you the table, fine. You are okay. But if he doesn't give you the table, you have to remember this formula. You have to remember this formula. Good. That is the formula. Listen, that is the formula for getting the present value of a future annuity. Listen, which is an ordinary annuity. If you are dealing with, of course, you now multiply this by 1 million. Get the present value, whatever it will be. Are you there? Now we want to get the formula for annuity due. For annuity due. Now, listen. For annuity due again, you are investing at the beginning. You are investing or you will be receiving at the beginning. Whatever the case, you are receiving your 1 million at the beginning of every year. Okay? So the formula will remain the same. Don't forget I told you, listen, just like when we were dealing with the future values of annuity. When we were dealing with ordinary, we lost 1 year. We lost 1 year of interest. The same, even when you are dealing with what we are calling the present values now. When you are dealing with ordinary annuity, you you lost 1 year because it comes at the end. Okay. Now for annuities due, you recover that 1 year. So it will be the same formula. If you want to get the present value of an annuity, it will be the annuity into 1, same formula, into 1 plus r to the power of negative n, everything divided by r, then you multiply that by 1 times 1 plus r. Multiply that by 1 plus r. That is the formula for annuity. That is the formula for annuities due. Okay? Good. So let's now put down those two formulas. We have discussed the two formulas for getting the present values. Don't forget, listen, don't forget, today we have just introduced the concept of the present value of annuities. And we are saying it's either ordinary annuity or it is either annuities due. If you are dealing with ordinary annuity, this is the formula. Good. So let's put down those two formulas, but first put down the subtopic. First put down the subtopic. First put down the subtopic, and the subtopic we are calling it present values. The subtopic is present value of annuity. Present value of annuity. Then you can see below there, again, types of annuity. Just to remind you again, types of annuities. Types of annuities. Though by now you should be knowing, but there is no problem writing them down. Again, 1, ordinary annuity. Put down ordinary annuity. Put down ordinary annuity. Then you say this, at the end of the period. At the end, or come at the end of the period. Those that come at the end of the period. Maybe you can put a dash by saying those that come at the end of the period. Those that come at the end of the period. Those that come at the end of the period. Then you can say here number 2, annuities due. Annuities due. Then you put a dash. Those that come at the beginning. Those that come at the beginning. Those that come at the beginning of the period. Those that come at the beginning of the period. Are you there? Good. Now we can quote the two formulas now. Then you can say there, for ordinary annuity, for ordinary annuity, for ordinary annuity, we have said the formula would be, what is the present value? What is the present value? It will be the annuity into 1 minus into 1 plus r, the power of negative n, the power of negative n, divide that by r. Divide that by r. This is to the power of negative n. The power of negative n. Okay? Then you come and say below that again, for annuities due. For annuities due, we have said the present value would be annuity, would be the annuity into the same formula, 1 minus into 1 plus r, the power of negative n, divide that by r, then you multiply everything by, this is n, the power of negative n, multiply that by 1 plus r. Good. But I've told you, if the examiner has given you If the examiner has given you the tables, then you don't need to cram these formulas. Otherwise, you only use them where the examiner has not given you the tables. Okay? So we want to do a few examples now. We want to do a few examples. So let me dictate a few examples. You can put a subheading there. Examples on ordinary annuity. Let's start with ordinary annuity. Ordinary annuity. Example of ordinary annuity. Example on ordinary annuity. So let's copy one simple example here. We have just been discussing, but let's now put example 1. Example 1. Put it down. Sema hivi. Put it down. Example 1. Sema hivi. If an amount of shillings 300,000, if an amount of shillings 300,000 is expected to be received, at the end of each year, at the end of each year, at an interest rate of 12%, for 4 years, at an interest rate of 12% for 4 years, determine the present value. Determine the present value. Determine the present value. Determine the present value. Good. Let's determine the present value. We are saying present value is equals to whatever is the annuity. You will be receiving 300,000 at the end of each year. So it will be annuity into 1 minus into 1 plus r, the power of negative n, everything divided by r. This is an ordinary annuity. So we know our annuity is 300. We know our R is 12%. We know our N is 4 years. So this will be 300,000 into 1 minus into 1 plus R, which is 0.12, 12%. Everything to the power of negative 4, you divide that by 0.12. You divide that by 0.12. So let's first get the discounting factor. This will be 300,000. Let's get the discounting factor. Multiply that by, let me first put it this way, that I start by simplifying, to be 1 minus into 1.12 to the power of negative 4, everything divided by 0.12, everything divided by 0.12. Okay, good. Let me simplify that further, just to help you understand. This will be 300,000 into 1 minus what is 1.12 to the power of negative 4. 1.12 to the power of negative 4. If I take to the nearest 4 decimal places, this will look like 0.6355. Then I divide that by 0.12. Let me finalize the bracket. This will be 300,000. Let me take whatever I got there, that is 1 minus 0.6355. I divide that which I'm getting by 0.12. 0.12. I am getting an amount to the nearest, it is 3.0375. Okay, that is that. Remember, I've rounded my power 4. The figure was longer, but I just rounded it to 4 decimal places to become 0.3 or 0.65, 0.6355. Okay, good. But now, listen. This is the discounting factor. Which one? Get my point here? The discounting factor is 3.0375 by using the formula. Let's go back to the table now that we have the table for the present value interest factor. Let's see whether we shall get that. Maybe slightly different because ours we rounded. When we were compounding the 12% 4 times, the power of -4, we rounded to 4 decimal. Otherwise, it should be the same. So let me see whether from the table that you will be given, if you are given a table, whether it will give you the same amount. So we are going to the column of 12. Are you seeing me there? The column of 12%. For how many years? 4 years. Good. I can see it here. The column of 12%. Are you there? The column of 12% there. And the row of 4 years. So I go down to the row of 4 years. I am getting 3.0373. 3.0373. Are you seeing it there? There. That's what I can see here. The amount is 0.3. The amount is 0.3. I don't know whether I can expand the page. Let me see whether if I expand the page. Good. So you can see it now. By expanding page, it has come clearer. This is the figure here. That is 0.0373. That is the amount. The column is 12%. The row is 4 years. This is the table for present value interest factor. Good. So if the examiner gives you the table, then you don't need to cram the formula. Otherwise, if he has not given you the table, you have to use the formula. What is the final amount? Let's quote the final amount. We have just multiplied. We have just got the discounting factor. Let me multiply that by 300,000. So this looks like 911 to 50. 911 to 50. Good. That will be the present value of 300 that is invested or being received at the end of each year. Good. That's example 1. Let's copy another simple example. Let's copy another simple example. Example 2 now. Let's copy another simple example. Example 2. Let's copy another simple example. Example 2 now. Let's copy another simple example. Example 2. Sema hivi. Copy this. Find the present value. Find the present value. We are doing example 2. Find the present value of an annuity. Find the present value of an annuity with a period payment, of shillings 2,000, with a period payment of shillings 2,000 for a period of 10 years. For a payment period of shillings 2,000 for a period of 10 years at an interest rate. At an interest rate of 6%. At an interest rate of 6% per annum. At an interest rate of 6% per annum. Compounded compounded semi-annually. Compounded semi-annually. Compounded semi-annually. So those are the payments. Listen, I told you even the other time, listen, the question does not tell you whether it's ordinary annuity or annuity is due. We said where the question is silent, take it to be ordinary annuity. That is the most common, ordinary annuity. Good. The other concept I've introduced now is that the interest is compounded semi-annually. So the formula remains the same. I hope you still remember. Formula remains the same, except that our R will now be divided by M. Okay? Good. So let's quote the formula, Bardo. Let's quote the formula. So our present value will be the annuity into 1 minus into 1 plus R. Remember now our R is not per annum. Our R we are compounding semi-annually. So I divide that by M to the power of negative N. The power of negative N. But we are compounding them semi-annually. So I'll multiply by M. Then everything I divide by R. Everything I divide by R. But don't forget R now is the rate per annum. I want the rate per 6 months because we are compounding semi-annually. So I divide this by M. I divide that by M. That is our formula now. That will be our formula. Let's put in the amount now. Let's put in the amount now. So our annuity is 2,000 into 1 plus R. Our R is 6%, which is the same as 0.06. I divide that by 2. You're getting? So that to get the rate per half a year. Are you there? Then everything to the power of negative what? We are investing for how many years? 10 years. Our R, sorry, this is negative 10. Multiply that by 2, because the frequency of compounding is twice in a year. Then I divide that by everything by R, which is 0.06. Divide that by 2. That's the formula that we want to use now. That's the formula. That's the amount. Good. So let's simplify this first. Let's simplify this. So this will be 2,000 into 1 plus 0.03. I have taken 0.06 divided by 2 to the power of negative 10 times 2, that is negative 20. I divide that by 0.06 divided by 2, that will be 0.03. Good. Then if I simplify this further, this will be 2,000 into 1 minus 1.03 to the power of negative 20. The power of negative 20, I divide that by 0.03. Good. What is the amount? What is the amount? Let me take that 2,000. I get my present value interest factor. I take 1.13. I take 1.13. 1.03, sorry. 1.03 to the power of negative 20. Whatever I get, I minus 1. Whatever I get, I divide that by 0.03. I'm getting an amount of 14.8775. Let me put it to 4 decimal places again. Good. Then we multiply that now and we get the present value now of the 2,000 annuities. It will be 2,000. Multiply that by 14.8775. This looks like 29,755. 29,755. Good. That's our example number 2. So I brought it because of the semi-annual compounding. I brought it there because of the semi-annual compounding. So finish. I go to the next concept. I go to the next concept now. Oh, maybe we can still do one more. Let's do another one more. Let's do one more. Another example. 3. Let's do another one example. Let's do another one example. Let's do another one example. So finish copying for those who are still copying. Okay. Let me hope you are through with the copying. Let me dictate another example here. Copy this now. Let me dictate another example. Put down this. Let me dictate another example now. Put down this. You won a lottery. You won a lottery. Full stop. The lottery officials offer you 2 choices. I've said you won a lottery. Full stop. The lottery officials offer you 2 choices for collecting your winning. They offer you 2 choices for collecting your winning. Another paragraph. You may take 4 payments. You may take 4 payments of shillings 25 million. You may take 4 payments of shillings 25 million each. You may take 4 payments of shillings 25 million each over the next 4 years. Over the next 4 years. Over the next 4 years. Or you may take a one-time payment of shillings 75 million today. Or you may take a one-time payment of shillings 75 million today. Another paragraph. Which one would you take? Which one would you take? If the interest rate is 10% per annum. If the interest rate is 10% per annum, which one will you take? If the interest rate is 10% per annum. So you have won a lottery. These guys want to give you your money. One way is to take, or one option is to take 4 payments of 25 million each, which means you'll take, in total, you will take 100 million. 4 times 25 is 100 million. But you take it over 4 years. Alternatively, they give you 75 million today as your winning. Which one will you take? So, of course, the second option is already at present value. So you don't have to calculate it again. So we are only calculating the present value of my 25 million at the end of each year. The one I'll be receiving at the end of each year, so that I get that 100 million that I'm going to receive in 4 years. What is the present value now? What is the present value now? Then I compare with the second option, where I can decide to take the 75 million, all of it at once. Good. So let's go by the present value, option 1. Let's put it down, option 1. Then you come and see your present value equals to annuity. into 1 plus r to the power of negative n, everything divided by r. Everything divided by r. You will be getting 25 million annuities at the end of each year for the next 4 years. So you want to know what is the present values of those 25 million, 25 million, 25 million every year. So this will be, let's put in the figures now. This will be 25 million into 1 minus into 1 plus 0. Our R is 10%. Our R is 10%, which looks like 0.1 to the power of negative 4. To the power of negative 4, everything I divide by R, which is 0.1, which is 0.1. Good. Then this will be, I simplify again, this will be 25 million into 1 into 1.1 to the power of negative 4, divide that by 0.1. So let me get this factor. That would be 25 million into, let me just multiply by so that I get the final answer. Of course, you can use the table where you go to the column of your 10%. The row is 4 years. Get the discounting factor. If the examiner has given you the table, the present value table of annuity, present value table of annuity, go to the column of 10%, go to the row of 4 years, where they merge, that gives you the factor. But because now we are using a calculator, let me just calculate it. 1.1 to the power of negative 4. Sorry, 1.1 to the power of negative 4. Then whatever I'm getting, I minus from 1. Whatever I'm getting, I divide that by 1. Oh my, I've clicked wrongly. 1.1, let me repeat again, to the power of negative 4. Whatever I'm getting, I subtract from 1. Whatever I get, I divide by 0.1. I'm getting an amount of 3.1699 to the nearest 4 decimal places. To the nearest 4 decimal places. Good. What is my 100 million going to be as the present value? So I take that 25 million, I multiply that by 3.1699. I'm going to get 247,500. Okay? So if you wait to be receiving 225, 25, 25, 25, then it's like you're cumulatively getting a purchasing power equivalent to 79 today. Are you getting? That's option 1. Option 2, you get option 2, you get shilling 75 million now. You get shilling 75 million now or today. Which one will you choose? Obvious, you want to know whether you are better. Where am I better? Of course, I'm better off in the first option because cumulatively, I'm going to receive more. Okay? Otherwise, if the option number 1 was giving me something like 70 million, then I'll go option 2. I take the 25 million because my purchasing power now is more. But if I wait, my purchasing power cumulatively today is the same as 79. So you come and say here, conclusion, you choose option 2. No, option 1, sorry. Choose option 1. Choose option 1. Good. We are concluded on that now. We are concluded on that. Finish. We want to do an example on the one for annuities due. We have done an example for ordinary annuity, getting the present value of an ordinary annuity. Now we want to do an example of annuities due. So if you are through with the copying, you can see here example on annuities due. Example on annuities due. Example on annuities due. Let's copy an example. Let's copy an example. Example on annuities due. Okay, say this. Say this. Mr. Kamau will receive. Mr. Kamau will receive 85,000 shillings. 85,000 shillings. A year will receive 85,000 shillings a year for the next 15 years. For the next 15 years from his trust. From his trust. Will stop. If 7% interest rate is applied, if 7% interest is applied, what is the current amount? What is the current value? What is the current value? What is the current value of the future payments? Of the future payments if the first receipt occurs today. 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 Okay? So, we are saying you are going to be receiving 85,000, sorry, for the next 15 years. Are you there? So our annuity there is 85. Are you there? 85,000. Our R, we are given 7%. Okay? Our N is 15 years. But the issue here is you will be receiving this 85 million. The first one will be received today, which means you are receiving it at the beginning. So it's an annuity that is due. That means it comes at the beginning. Let's get the present value now. We come and see your present value equals to annuity into 1 minus into 1 plus R, the power of negative n, everything divided by R. Then I told you, you now multiply by the factor 1 plus R. You now multiply by the factor 1 plus R. Now multiply by the factor 1 plus R. Good. So let's put in the figures now. Let's put in the figures. Our annuity is 85,000 into 1 plus 0.07. Our R is 0.07. Are you there? We have our N being 15 years, so we have to the power of negative 15. Divide everything by 0.15. No, 0.07. 0.07. Then whatever I get, I multiply by 1 plus 0.07. This will be 0.07 plus 0.07. Let me squeeze it properly. So that you can see it. This will be 1 plus 0.07. Okay? This will become 85,000 into 1 minus 0.7, sorry, the power of negative 15, divide that by 0.07, then everything you multiply by 1.07. Multiply by 1.07. Good. And this will be 85,000 into, let me get what is in bracket, all of it first. Let me get what is in bracket, all of it. I take 1.07 to the power of negative 15. Whatever I get, I subtract from 1. Then whatever I'm getting, I divide that by 0.7. That is giving me, maybe I can put it this way. I can put it times 9.1079. Multiply that by 1.07. Multiply by 1.07. Good. What is the final answer? To be 85,000 times 9.1079 times 1.07. This becomes 828 363.5. Good. So that's the answer for that. So we have we have discussed today the present value of annuities, the present values of annuities. We have done several examples, either annuities due or ordinary annuity at the present value. Finish. I want to develop the topic slightly. Now. So finish copying. If you are still copying. So we are still on annuities. We are still on annuities. If you are through with the copying, we are still on annuities. Now listen. Suppose these annuities that you are going to receive. Listen. Suppose these annuities that you are going to receive, they are going to be received forever, into perpetuity. We have been discussing how to receive the annuities every year for 10 years, 10 years, and so on. But not if you are going to receive these annuities from this fund, you are going to receive them forever, into perpetuity. How do you get the present values of those future annuities which you are going to receive forever? So there is a formula again for getting the present values of future annuities which are going to be received into perpetuity. So maybe you can put down the subtopic first. Put down the subtopic, andika present value present value of annuities into perpetuity. Into perpetuity. Perpetuity. So put down the formula. I put down the subheading. Present value of annuities into perpetuity. So you're going to receive 1 million, 1 million, 1 million from your fund. From your fund forever. How do you get their present value? Listen, what you will do, you will take that annuity. Let me explain. Get the present value. You will take whatever is the annuity, multiply by 1, divide by R. That is the formula. In other words, listen, in other words, you are taking R annuity, you are dividing that by R. In other words, you are saying, listen, when you divide an amount of annuity by the rate like 0.1, what you are doing is that you are capitalizing. It's what we call capitalizing the annuity at the rate of interest of 10%. So it's like we are capitalizing the annuity at whatever rate of interest. So when you are determined or when you are required to get the present value of an annuity into perpetuity, you just take that annuity, you divide that by the rate of interest. Are you there? You take the R, the annuity, which is A. I have said it's the same as multiplying by 1 divided by R, which is the same as saying it is A divided by R. So that will give you the present value of those future annuities, the present value of all those annuities that you will be receiving into perpetuity. Let's put down the formula. Let's put down the formula. So andika present value equals to present value equals to the annuity, I've said you multiply by 1 over R, which you can say equals to annuity divided by R, which in simple is the same as A divided by R. It's A divided by R. We can represent A to be the annuity. Okay? So some questions you are given where you are told to get the present value of an annuity. Present value of an annuity. So maybe we can put a simple example down. Let's put down a simple example there. Let's put down a simple example. Let's put down a simple example. The key thing is just to know that if it's an annuity you are going to receive in the future into perpetuity, just take the annuity divided by R. That will give you the present value of that annuity. That will give you the present value of the annuity. So put down this. Mr. X wishes to find out. Mr. X wishes to find out investments. Wishes to find out investments which return shillings 1 million per annum. Which return shillings 1 million per annum, discounted at 10%, discounted at 10% into perpetuity. Discounted at 10% into perpetuity. Into perpetuity. Into perpetuity. Good. So let's get the present value. So andika hapo determine the present value. Determine the present value. So we come and say your present value equals to A divided by R. This guy wants to find out an investment which will give him a return of 1 million every year into perpetuity. What is the present value? You divide that by R. Our R is 0.1, is 10%. So to me that is simple. That's 10 million. That is 10 million. Good. So that is it. That is how we shall be getting the present value of an annuity into perpetuity. Into perpetuity. Finish. I mentioned one or two other concepts. Now, listen. We can put this in summary. We can put this one. Let me put it correctly so that you get it. This is what we are calling present value interest. Present value. Not that one. This is present value. It's this one. Present value interest factor of annuity. Okay. Maybe I can just put it here. There is no difference. Present value interest factor of annuity. Present value interest factor of annuity into perpetuity. Listen, our perpetuity, we normally put it to the symbol that way. You want to get the present value interest factor of annuity into perpetuity. Okay. Okay, the same. What I could do is this. Let me put it right. Allow me to put it right. Let me not mix you up. Listen. This will still remain present value. This will still remain present value. But the one I'm referring to, maybe I could put it clear. The one I'm referring to as present value interest factor of annuity into perpetuity, it is this one divided by R. That is the present value interest factor. Get the point there? So that when you multiply now by the annuity, you get the present value. Maybe I can put it that clear now. That to get the present value interest factor, the way I was taking 1 plus R to the power of n, that was the factor. Then you multiplied by the annuity, whatever it is. Now we are saying, get the present value interest factor of annuity into perpetuity. It is 1 divided by R. It is 1 divided by what? R. That is the factor. That is the factor. Good. Okay. Now, let me now go on. I hope you have understood that clarification. I took the first time, I just multiplied everything. This was our annuity. Listen, that was our annuity, but our factor was which one? Our factor was 1 divided by R. Just like we were taking the annuity, multiplying by the factor. So our factor here is 1 divided by R. Make sure you get that. So that the final answer is the same as taking annuity times R divided by R. But the factor, the present value interest factor, is given by 1 divided by R. That's important. 1 divided by R. Then when you multiply by the annuity, now you get the present value. Now you get the present value. I hope you are getting that point now. Good. Now listen again. Now listen. Now, what if, listen, I want you to get it right. What if your 1 million that you are going to be receiving, your 1 million that you are going to be receiving is that annuity into perpetuity, but it will be growing. We call it a growing annuity. Year 1, you receive 1 million. Year 2, you receive 1 million, but it is growing at maybe 10%, which is 1.1 million. So these are annuities, but they are growing annuities. They are growing annuities. How do you determine their present values? So write another subheading, write a small subheading, present value, put down another subheading, present value of a growing annuity, present value of a growing annuity to perpetuity. Present value of a growing annuity to perpetuity. What is how to get the present value? It will be, put down the formula, it's not a long one, present value of an annuity to perpetuity, but a growing one. It is given by the formula as annuity of period 1. Annuity of period 1, divide that by R minus G. R minus G. Or maybe I can put it in full so that when I put it in, this is R is cost of capital. Cost of capital is R minus growth rate. We call it growth rate. Then you can put it this way. This will be given by A1. We'll talk about that in a short while. Divide by R minus G. Divide by R minus G. Let me explain. Our annuity is 1 million. Our annuity is 1 million. But what will be the annuity of period 1? It will be 1 million times 10%. It will have grown by 10%, which will come to 1.1. That's what I was trying to say. So the annuity of period 1 is 1.1. I'm not talking of the annuity of period 0 at the beginning. No. You are getting the annuity at the end of period 1, which is 1.1. You divide that by R, which is 0.1, minus the growth rate. You minus the growth rate. Whatever is the growth rate, that's what you do. That's how you determine. Of course, they are not common in your exams, but just for the sake of knowing, how do you determine the present value of a growing annuity into perpetuity? So the formula is A1. What does A1 represent? It represents the annuity of period 1. You divide that by R, which is the cost of capital or the interest rate, minus whatever is the growth rate, whatever the question will be giving you as the growth rate. Good. That is all I can say about the discussion for today. So today we have discussed how to get the present value of future annuities. Then we have also done examples. We have done examples. We have done examples of those future values of present values of those annuities, whether annuities due or ordinary annuities. Then I've talked about what if it is an annuity to perpetuity. You're going to receive 1 million, 1 million, 1 million, 1 million to perpetuity. How do you get, listen, how do you get the factor? Not the amount first, the factor. The present value interest factor is given by 1 divided by R. That is the factor. Then to get the present value, you now multiply by the annuity. You now multiply by the annuity. Good. Then I've said, how do you get the present value of a growing annuity? How do you get the present value of a growing annuity into perpetuity? It is given by the annuity of period 1. What is the annuity number 1? The beginner was 1 million. It will grow at 10%. 10% of 1 million is 100. Add to 1 million. That gives you 1.1. That becomes the annuity 1 or annuity of period 1. You divide that by R, which is the interest rate, minus the growth rate, whichever the growth rate the question will give you. Mine, I'm assuming it will grow by 10%, whatever it will be. Good. So maybe we can stop there. Next time, we shall also do some few calculations. For that, we shall do a few calculations, especially for one relating to annuity to perpetuity. There are some questions that have come. I've given you one here, a simple example, where we have got the present value to be 10 million. Good. Allow me to stop there for today. We pick it up from there next time. We now pick it up from there next time. Bye for now.